Okay, this is lesson 2.8, radical expressions. Definition of a radical expression is any expression that contains a root sign. And some examples you see below are like the square root of 2, or 3 times the square root of x, or the third root of 2, or even a fractional exponent is also expressed as a root. 2 to the exponent 1/2 is the same as the square root of 2. The top of a fraction indicates the exponent on 2, and the 2 on the bottom of the fraction indicates which root of 2 you're taking, and it's the second root or the square root. We'll look more at fractional exponents later in the course. But for now, I'm more concerned with these ones, the ones that are actually written as roots. In terms of characteristics, you can have a few different parts to a radical. You can have a number in front multiplying, and that's called a coefficient. The expression inside the root, this x minus 4, has two names. It can be called the radicand or the argument. What root you're taking, in this case the third root, is called the index, and the actual root sign is the radical. Some non-examples are some things we've seen before. Polynomials aren't radicals, rational expressions aren't radicals, and trig functions like sine, they're not radicals either. In this video, we're going to explore two things. We're going to simplify radical expressions to make them as simple as possible, and then we're going to multiply and divide them. A radical is in its simplest form when the radicand, the thing underneath the root, is positive and doesn't contain any perfect square factors other than 1. So a perfect square factor is something you can take the square root of nicely. So numbers like 1 or 4 or 9 or 16, 25, those numbers can be square rooted. And if any of those numbers are factors of what's underneath the root, you can simplify that radical. The radicand can't contain a fraction, so we try to simplify that as much as possible. And the denominator does not contain a radical. So we'll go through a couple examples and show you what I'm talking about here. First one is the square root of 75. Simplifying a radical is very much like simplifying a fraction. You can reduce it and make it simpler, and the way you can do it is by splitting a radical up into more than one radical, and I'll show you what I mean by that. The square root of 75 can be split up into two radicals. It can be split into the square root, I don't know if I said square root of 75 or the square root of 25, but it can be split into the square root of 25 and the square root of 3. Because if you multiply the square root of 25 by the square root of 3, you do get the square root of 75. Now, why might you do this? Well, the reason you might do it is because you can actually square root 25. If you square root 25, you get 5. And you can't square root 3, so you keep it as a root. And what this simplifies to is 5 times the square root of 3. And like some calculators that will simplify fractions, there are also some calculators that will simplify roots. I'll show you what I mean here. If I use my Casio and I take the square root of 75, my calculator will give me 5 root 3. It will simplify that root, just like it would reduce a fraction. Okay, like if you wrote a fraction in, like say 2 over 4, my calculator will simplify it. So simplifying or reducing a radical is the same as simplifying or reducing a fraction. And it's proper form to write your radicals in fully simplified form. And we can do that by finding any perfect square factors that we can divide away. Or sometimes you can divide away common factors. So in example B here, I have the square root of 48 divided by the square root of 6. Well, 48 can be split into 6 times 8. So the square root of 48 can be split into the square root of 8 times the square root of 6. And why would we do that? Well, the reason we do it is because now we have a common factor on the top and bottom of our fraction. And if you have a common factor on top and bottom, you can divide it away. And you're left with just the square root of 8. Now the square root of 8 in itself is not fully simplified. How come? Well, because 8 has a factor that's a perfect square, and that factor is 4. So we can break 8 down into the square root of 4 and the square root of 2. And I'm going to finish my answer up here. And if you take the square root of 4, you get 2. And you can't take the square root of 2, so we leave it the way it is. 2 times root 2 is the simplified form of the square root of 48 divided by the square root of 6. I check that one on my calculator. Now, not all calculators will do this, so I do need you to be able to do this without a calculator, but we can check it. Made a mistake here. Square root of 48 over the square root of 6. 2 root 2. And C, if you have the square root of a fraction, you can change that into the square root of 2 divided by the square root of 9. It's like if you had 2 over 9 squared. You would square the 2 and square the 9 to simplify it. Same with square root. Okay? And you can actually take the square root of 9, which is 3. So we're left with root 2 over 3. And now we have a fraction, but we don't have a root in the denominator. So this is fully simplified. This radical is fully simplified. Now, if we did end up with a root in the denominator, well, the next lesson will show you how to deal with that. But for now, we're just simplifying ones that won't. So what if we're multiplying and dividing? Well, if we're multiplying two radicals, the way it works basically is that we're going to multiply the coefficients and we're going to multiply the radicands. So the stuff on the outside multiplies and the stuff on the inside. And then we try to simplify it. So let's give one a shot. We've got 9 root 2 times 4 root 7. So start by multiplying the stuff on the outside. 9 and 4. 9 times 4 is 36. And then we have our radical. And then we multiply the stuff inside the radical. 2 and 7 is 14. And now we look to see if we can simplify the radical. Can we split 14 into two factors, and one of which is a perfect square? Well, the only factors of 14 are 1 and 14, and 2 and 7, and the only one of those that's a perfect square is 1, but taking the square root of 1 just gives you 1, so it doesn't actually change anything. So that's as simple as this one gets. Let's try another. B, 2 root 3 times 5 root 6. Start by multiplying the numbers in front of the root. 2 and 5 is 10. And then multiply the numbers under the root. 3 times 6 is 18. And 18 can be simplified. Or sorry, root of 18 can be simplified because we can split 18 into two factors, 9 and 2, and 9 is a perfect square. So let's split it. 10, root 9, root 2. And if we take the square root of 9, we get 3. So what we have now is 10 times 3 root 2. And 10 times 3 is 30 root 2. So multiply the coefficients. 2 times 5 gives you 10. Underneath the root, 3 times 6 gives you 18. See if you can simplify what's under the root. We can. Root 9 and root 2. Actually take the square root of 9, you get 3, and then multiply the two coefficients now to get one coefficient. Last example, C. We've got 6 minus root 45 over 3. And this expression is actually fine unless we can simplify the root. So let's look. Is there something that we can split 45 into? It's two factors, one of which being a perfect square. Well, 9 times 5 is 45, so we can split 45 into root 9, root 5. And as you get more efficient, if you figure out that it's root 9, root 5, you might go right and square root that 9 right away and just write 3 root 5 as you get more efficient. And that's fine. You don't have to show this step every time. Square root of 9 is 3, so 6 minus 3 root 5 over 3. And now, on the top, you may notice there are two terms, a constant term and a radical term. Well, they have something in common. They both have a common factor of 3. We can divide both of these by 3 because the coefficient on our radical is 3 and our constant can be divided by 3. So let's common factor 3, and that'll allow us to simplify this a little bit further. 3 from 6 would leave us with 2. 3 from negative 3 root 5 would leave us with negative root 5. And on the bottom we have a 3. Now we have a factor that's common on top and bottom, 3 and 3. So we can divide it away. There's my answer up here. And we're left with 2 minus root 5. And if you have a calculator that can reduce radicals for you, you could type all of these in from the beginning and they would give you the final answers. Okay? But again, what's important here is the process. You need to be able to simplify radicals on your own without a calculator. That's it actually for lesson 2.8. Thanks for watching, and I'll see you next time.